Hey folks, it's Rob Flux here with another Sunday session, and today we're talking all about lifts, the luxury level up that you're going to want in your next development for a whole range of reasons, both from how do we actually make our products look and feel more luxurious, and I guess more importantly though, we need to make them future-proof because we've got an aging population, and as they get older, they want to, I guess, age in place and be able to traverse up and down floors. So whether you're doing a small duplex all the way through to high-end apartment complexes and the like, we're going to learn all about that today. So all about lifts. And so in order to do that, I've got a very special guest, Effie from Schindler Lifts. So Effie, welcome aboard.
Thank you. Thanks for having me here today, Rob.
That's okay. So firstly, let's hear a little bit about Schindler Lifts. And I think you said you've been working for them for about 17 years. So what's your little journey in Schindler?
Yeah, I have. I've been with Schindler Lifts for 17 years, as you mentioned, coming through right from the bottom as in the marketing department, and then moving into fulfillment. So really driving the operations here with the operational team for a long time, and just recently moved into a sales director role. So yeah, it's been quite the challenge. It's been exciting, but it's a great company to work for, to be honest.
Very good. So tell us a little bit about Schindler. I guess. I'm sure that we've all jumped into a Schindler lift at some point in time and we've seen the little badge, but who are they? Where are they? I guess, how long have they been around?
Yeah, sure. So Schindler is a Swiss-owned company. We've been around since 1874 here, to be honest, and we've been moving billions of people every day in the lifts, that we install. We specialize from anything from residential to, really large commercial towers in the city, modernization as well. We modernize lifts. If you have an existing building, we can come in and work around spatials that you have and fit a lift in. So we touch a lot of different buildings and segments in the Australian market, and we do have branches and offices in all the major states. So
very good. So what we're going to try and do today, we're going to take everybody on a little bit of a journey. We've all got into a lift and press the button and we know that it takes us somewhere, but we're going to take them under the covers and try and say, well, what actually goes into the components of a lift? What are the things that you need to start to think about with regards to I guess designing your building for a lift, I guess, and then some of the sizings and all that sort of stuff. So let's start with like the super basics. We all get into the lift, but there's actually a lot of components to a lift. So what are some of the things that people don't realize? So the lift itself is not actually called a lift. You told me before it's called a cabin. So that's the first part that I didn't know. What else do I not know?
Yeah, so as you said, most people just jump into the lift and it takes you from A to B, but behind the scenes, there's a lot going on. So we have the actual cabin that rides on rails. So there's rails and brackets in the shaft, and the shaft is the well that the lift sits in. You've got, the machine that sometimes sits in another room on top of the shaft. Other times it sits into the shaft, which is called an MRL, machine roomless, which is what a lot of the smaller residential buildings use. And then we have pit. The pit means it's the area beneath the lift at the bottom floor, which we have pit gear in. So it doesn't go to a complete ground. There's definitely space under there, which we have safety mechanisms there to make sure if the lift does go down, it sits on a buffer or it lands on a buffer. So yeah, there's a lot of components in the lift shaft that many people don't see, especially on top of the car as well. We have a door operator, which functions the doors inside the car, and then you have doors external, which sit on the landing, right? So there's two sets of doors. A lot of people don't know that. They think it's one. So yeah, that's basically, you've got the ropes as well and belts that actually go through into the machine onto the car that actually drive the car up and down, traction machine. So yeah, that's a bit about what people don't see in the lift shaft.
I think there's also a counterweight that sits in there. Quite often when we see lifts that are exposed, you see the weight go up and down.
Correct.
Yeah. So and basic year 12 physics, I guess trying to lift a heavy object all by itself is actually a lot of work. But if you've got a counterweight, so as you're trying to lift something up, another piece of weight is going down at the same time. The differential is actually what the lift is actually working on.
Exactly right.
Makes it much simpler in order to do that. So that's why you see those weights go up and down. So so a lot of components, and the lucky last one is the actual controller itself, the actual brains of the machine. When you press the button, I guess the box underneath that does a whole bunch of magic. And depending upon the complexity and the size of your building, that brain might be super simple, or it could be super sophisticated, doing all sorts of thinking on your behalf.
Correct.
Yeah, so I was watching I think I was telling you this just before the show. I watched a show nearly 10 odd years ago on YouTube talking about the brains of a lift. And I know that everything's moved on since then, but the things that I just didn't realize when we're talking about high-rise buildings is I guess how the lift is super intelligent and actually thinking for you. So from grouping people into I guess the same cabin when they're going to same or similar floors, to at the start of the day in an office tower, always landing at the bottom, so they're always picking up new guests and nobody's waiting, to the end of the day knowing, I guess, which floors are the busiest and that sort of thing. So it kind of monitors and manages all of that. And that was 10 years ago. I'm sure it's moved on a hell of a lot since then.
Yeah, there's a lot of smarts behind, new technologies. We call it port technology, which exactly right, groups people. It creates efficiencies in lobbies, people traveling up the building, much more efficient. We can do all sorts of things, key off floors for certain residents that only want to go to specific floors with that technology. It's unlimited what we can do with the lift and how you want the actual building to run. We can tailor it with your lift services. So yeah, it's amazing.
Very good. So, okay, now we know the components of a lift. I want to start to talk about the technologies that sit within some of those components of the lift. And I want people to kind of have a little bit of an understanding also of what that feels like when you're actually inside the lift, because they have a very different and distinct feel when you actually step inside. So we'll go to the bottom of the range, hydraulic lifts. That is a hydraulic ram that sits in the pit and mechanically pushes up the lift, I guess, with hydraulic fluid. My experience in them is they kind of, when you're in the cabin, it kind of shakes and it's a little noisy and have I got that right? Am I talking out of my hat?
No, that is correct. So the hydraulic ram system, like you said, uses the oil and the ram to actually push the lift up. So basically you do get a bit of a shaky ride, and you have an oil tank basically down the bottom in a machine room, that feeds the ram. So yeah, it's very clunky. It's a clunky system. That is pretty old technology now. We've moved away from that. We're using the traction lifts, which you'll see in most buildings these days. And the ride quality in that is much more seamless. It's quieter as well. There's no need to, look at the oil in the hydraulic ram or in the tank. We've moved away from that. It's more, energy efficient now these days as well. So MRL is definitely machine roomless is the way to go. Traction machine roomless.
Yeah, so we'll talk to that in a sec, because when we say machine roomless, that infers that there is lifts that actually have a machine room. So we should probably talk to that. They go, well, the other end of the extreme, other than I guess a lift pushing it up, the machine room on top is pulling the lift up, which is very, I guess, completely different. So mechanisms that sit, and quite often we'll see above a high-rise building, there's an extra little box that's sitting on top of the lift well, where all the machinery is actually sitting. So that's the other end of the extreme. So what kind of sits in that machine room?
So in that machine room, you have the machine itself, which is doing all the driving. You'll have typically the controller up there as well. So we're seeing that a lot of modernizations of older buildings now are actually using that room for storage or other purposes, because once you modernize and remove that machine and go to a more, energy efficient MRL machine, that room is, utilized for other purposes. So yeah, typically in older buildings, you will see that machine room up there. And again, it's the machine, the controller, the drive, things like that. But yeah, slowly, we're moving away from that machine room and going to an MRL machine now.
Yeah, and for anyone that is doing, I guess, medium-rise apartment complexes, that has always been a limitation of actually getting the lift to the roof itself, because you kind of need, if you want the lift to get to the roof, you need a machine on top of the very last floor, and so that's always been a limit. If you're having I guess a garden area or something with open plan living on the rooftop garden, that's been a limitation. But with the new technology, what is called I guess traction lifts, you've said it's machine room less, so therefore no machine room required. Where does it all go?
So at the top of the shaft, we have an additional space. Obviously, we need overhead room, but the machine sits on a wall inside the shaft, which makes that machine room redundant. What we do have now is the controller now, which sits, instead of a machine room, it sits either on the top floor or the basement floor, so it's hidden away. And that controller is really used by technicians if anything happens to go and, do their mechanics and reset the lift and things like that. So they can actually see inside the lift while they're working on that controller being on the top floor or on the bottom floor now. But everything's really compacted for ease of, the building in the new buildings. We want less space, we want it all compact, so that's where we put all our mechanical items now.
And I guess those traction based lifts, and I know that you're not a technical person, but they're not using mechanical systems in the way that we were before with a hydraulic system and things like that. The maintenance that's required on them is a hell of a lot less, but obviously maintenance still required, but nowhere near to the level before. But it's smoother ride, and largely electricity. From a technology perspective, we just kind of need to plug in power and off we go.
Well, there's a massive energy reduction from a hydraulic to a MRL these days. Like, it's a substantial amount. So yeah, it's definitely the way to go.
And we didn't ask this, I guess, in our pre-chat, so I hope I'm not catching you off guard. But from a power requirements perspective, do we have any understanding? Is it like a 10 amp, 15 amp, 20 amp? What's if we're wanting to design for the future and we want to put a lift well in place and maybe put a lift in 5 years' time or something like that as we get a little bit older, what should we actually plumb for from an electricity perspective?
So we're going to need three-phase power. Three-phase power, definitely. Yep, three-phase power. So it does, to kick over a machine, depending on the size as well, right? There's certain amperage that we will require, and it depends on the size of the machine and the size of the lift. So it can vary.
Okay. So, but there's a key gotcha, folks. If you're kind of designed for the future, make sure that you're actually engaging for three-phase. So, okay, we know kind of now what goes into a lift, but we don't really know how, I guess, a lift operates. There's a whole bunch of safety mechanisms that are actually built in there that as you touched on, because I personally have been trapped in a lift before and that sort of thing. What are some of the safety mechanisms that are either standard in every lift out there, or I guess optional extras that people may want to choose to think about depending upon their client base?
Yeah, look, there's heaps of, safety components that are attached with a lift. But the one that you should really, we should really highlight is the AED. So when the lift goes into a stop, the AED, automatic evacuation device, or some call it rescue device, basically has a battery in the AED, and it lowers you to the nearest floor. Now, what that means is basically you don't have to get emergency services out to break your doors down. It will go down to the bottom floor, the closest floor, and open its doors and let you out. So then, you cost saving for that repair bill if emergency services do come out and try and break the doors open.
You're not paying to fire an ambulance to turn up at the same time and then because they've ripped the door off, have to replace the door. Yeah, I've been trapped in a lift for half a day before, so I guess glad that those sorts of things are there. But I guess there's also things like emergency brakes and stoppers and things like that. So which I would anticipate would be standard in every single lift. How do some of those
100%.
How do some of those things work?
So if the lift goes into fault, the emergency brake is definitely engaged, and basically the lift comes to a halt, and then it just grips onto the ropes and to the brackets. So there's a few other emergency engages. Again, I'm not technical, that do get triggered as well. So there's no way a lift will fall. A lot of the lift fell three stories or 3 floors. I felt it. There's no way that would ever do that. The emergency brakes engage, and it feels like you're falling, but it's just a shutter. So there's definitely no way that the lift would definitely drive down into the ropes or down 3 floors. So that's a misconception that a lot of people have.
Oh, it's all from the movies. Like you see,
Exactly right.
on the movies. So, and
Exactly right.
you see them trapped halfway in between floors and people climbing out, and you're waiting for it to drop at that moment in time and cut them in half. But
Yeah.
that doesn't happen. That's what you're telling me.
It doesn't happen. There's the brakes that engage. There's emergency or basically underneath the car. There's also safety mechanisms, but there's always the alarm button inside as well that you can call the call center as well if you ever get stuck in a lift, and they will dispatch someone straight away if you ever find yourself in that situation.
So thank you. They're the safety mechanisms. What about I guess value adds and premium uplifts? If we want to make a lift have a little bit more wow factor, I'd anticipate there's things in around the energy efficiency space that they do. So what are some of the things that we can do there?
So for the energy efficiency space, basically we have the auto reduced lighting. So when you're not in the car, the lighting actually goes out, which creates more efficiency. We also have the regenerative drives that come standard, in all our machines. So there again, we reduce efficiency, but really you get a lot more efficiency the larger lift you go as well with the regen drive. Not to say you don't get it with the smaller stuff, but you don't reach that max capacity of drive in a smaller lift. But the auto lighting and bits and pieces like that really create that efficiency compared to an older lift where the lights were on all the time.
Yeah, so that regenerative energy that you're talking about works very similar to an electric vehicle, how it regenerates when you're actually braking. So the same thing is actually happening in the lift. I guess as it's using energy to slow down for, I guess, the next floor as it's dropping, it actually uses that to charge up the battery. So the next time it then uses a surge to pull it up. So it's not quite completely self-sustaining, but we're getting there.
We're getting there for sure. The technology is definitely improving year on year. There's new innovations that are, R&D are working on every year, and hopefully by 2050 we'll have a lift that purely works on regenerative power. So something to look forward to.
I'm looking forward to teleportation. Are you leading the charge on that? Okay, other features for people to start to think about might be remote monitoring. So probably not as important if you're in a single house and that sort of thing, but if you're in an apartment complex and that sort of thing, you don't want people complaining about a lift breaking down in the middle of the night or things like that. So remote monitoring and having people actually physically seeing, I guess, the status of the lift, I'm sure that's capable.
Yeah, so even if you have a 2-story villa or a luxury home, it's quite important to have remote monitoring. We call it the cube. It's a little contraption that sits in your shaft, and it monitors the lift. So if there is a door issue that you're unaware of, and it hasn't actually come to light yet, this system can pick up and detect the system and where faults are. And if it detects a fault, sometimes it can reset itself to see if that fault clears, and other times it will alert the technician before you even know there's an issue about the problem, and then you'll get a call out to rectify that problem. So remote monitoring is a great innovation, and it lets us see where the lift is it working at full capacity? Is there an issue? Can we rectify that issue remotely, or do we have to call someone out? So whether it's a 2-story building or a 30 or 40-story building, I think it's quite important to have that on there.
Yeah. Next one will be control access devices. So if you're in a multi-level type apartment and your story is, so you live on the 3rd floor, having things like swabs or pin codes or things like that, so it only takes you to your floor and no one else. We see it all the time in hotels, but how sophisticated are those things? What can we do with those?
Yeah, so as we mentioned before with the port system, it basically, like you said, it groups people, but it also does a lot of different things, right? You can pre-detail the card that person is only allowed to a certain floor. That's with the port system. If you're going conventional systems, which is the buttons up and down, you can definitely use an access card or key switches inside the lift. But again, early engagement with your vertical transport supplier to make sure you understand what you require, to make sure we have all the right necessary, wiring and key switches in place when we do go to install your lift is crucial as well.
Yeah, so I'll just kind of flesh it out for those who haven't come across the port system before. If you go into more modern, I guess, commercial buildings, quite often you get into the lift and there is no button. And then when you step outside, there's a panel where you actually say what floor you actually want to go to. You press that button, and then it uses a whole bunch of smarts in the brain, because usually there's multiple lifts in that building, and it understands how many people are going to what floor, and it'll try to call just one lift to take all of them to the same floor, rather than having 4 lifts go to the exact same floor and everybody else twiddling their thumbs. So that's the port terminal. And then I guess the keys and the fobs that we were talking about before, we're probably more used to when we go into a hotel. You actually get in, there is a button, but you got to swipe and then press your button.
Yeah.
Just so that everyone's kind of got some concept on all of that.
Yeah. You'd have to engage obviously security provider, and then we work together with them to make sure that, whatever you're requiring in terms of your building, whether it be a fob, a key switch, whatever it may be, that we align and make sure that we, have the right protocols in place for your building.
Yeah. So, okay, we kind of understand what goes into a lift, what how the technology works and that sort of the thing, but we haven't worked out the sizing. So obviously there's the old small, medium and large type thing, depending on what we're actually trying to do.
Yep.
And similar in, I guess, in your organization, you've got small, medium and large, but your small is actually not that small, but your large is very, very large. So without getting into, I guess, the product ranges and things like that, they're basically limited by a combination of weight capacity and height restrictions. Is that right?
Yeah, correct. So we definitely work off what capacity you would like the car to be, and then we work with you to figure out what dimensions we can provide you in terms of lift car heights and widths and sizing. And then, once you pass 12 meters, if it's a residential building, you have to follow certain codes and standards, which is, the AS 1735, which you have to comply to the stretcher compliant code, which means you have to have a certain size car or cabin.
So effectively, if you're doing anything in a public space, so if you're in apartments or things like that, then it needs to be large enough to have a stretcher for the ambulance to come and go. But if you're inside your own one individual dwelling, you don't have those restrictions apply. And I guess they assume that they can crumple you up in a heap and just push you in the corner and go down that way. No stretcher required.
Pretty much.
So, but I guess the first part to that, I guess with the minimum dimensions in the public space, but if we just talk about weight categories, if we're wanting to do, I guess, a smaller residential, I guess your bottom of the range still actually has 3 different weight categories. So what are those 3 different weight categories in the bottom of the range product?
Yeah, so our 3000 range covers off on the 400 kilo, 535 kilo and 630, which is our most popular for moving, furniture in and out, fridges in and out. That seems to be the most popular. And, the sizing for the car for that would be 1400 by 1970. Again, we can tailor, we have a few car sizes. We are limited, obviously, but, we can tailor it to your needs and your requirements and how you want the lift to look and feel, inside your dwelling.
So 1400 by 1970, is that what you said?
Yep. Yes, correct.
So near enough to 2 meters.
Pretty much.
Yeah, just that shy short. Now, the fact that there are different weight categories is probably an important distinction, because on a day-to-day basis, a couple of people getting in and out, we can all kind of easily look around and see, who are the shorties, who are the tallies, who are the, I guess the big boned people. We can kind of speculate on what the weight requirement are, knowing what that usage is on that property.
Yep.
But it's the oddball instances, and you did touch on it, when people want to use the lift to actually get furniture in and out and those sorts of things. We need to be conscious of that, I guess, day one, when we're actually putting it in, to go, well, if we're going to put this into a public apartment complex, then when we're not looking, somebody's bound to be an idiot and stick a fridge in there, and probably a couple of other things. But when we're in an individual home, we've probably got some more common sense that might be applied. So typically, you touched on the most common one in that the smaller apartment complex is about the 630 kilo mark. Is that what I heard?
Yeah, that's the most common one that we see, well, in the sort of smaller residential space. But then you go into your larger sizing, which is the 1,000 kilo, the 1,350, 2 ton even, depending again on what requirements you would like in your dwelling or your building or your small residential complex. Yeah.
But we can scale that all the way down. If you're just doing a 2-story or 3-story townhouse, and it's just one person or one family actually utilizing that, you can go all the way down to about 400 kilos, where people are going to be a little bit more sensible in that
Correct.
space.
Yeah.
So we've got the weight, I guess, restriction. Then you said that, I guess, the dimensions of the cabin itself, and so the smaller one, I think you said, was 1,400 by 1970, but the next category up, when you actually go into the public space, is that where that 1,400 by 1970 comes in? Is that because of that stretcher requirement?
Yeah, the stretcher requirement, minimum stretcher requirements for 1,400 by 2,000. So they stretch it in and maneuver it around and pull it back out. And hence why that's the minimum dimension.
Yeah. And so as you go up in your weight categories, then equally, I guess, the size of the cabin would tend to go up, because it's not like you're going to jam more people into the same space to get the same weight. So when you go up, I guess, to your mid-range series, what's the I guess, cabin dimensions in there?
Most popular would be 1,450 by 2 meters. And again, it could go up a little bit more than that, but that's the most popular range that we see in that category.
Yep. And from a height perspective, sorry, when I say height, I'm not talking about how tall inside the cabin. I'm actually talking about how high can the lift go. Even your bottom of the range teeny 400 kilo one, that's not restricted to just 2 stories, is it?
No, definitely not. It can definitely go up to 12, 15 stories. So, it depends on what you want again in your building, but we do have a large range. Again, the 3,000 series could definitely meet requirements for a small residential building that, you might be developing.
Very good. Okay. So I guess there's a couple of things for us to be thinking about now that we kind of know dimensions and sizings and capabilities and stuff like that. Some of us are probably wanting to put a lift in day one, and some of us are probably wanting to future-proof our buildings to say, look, I'll give myself as an example. I have to go up 4 flights of stairs. Right now, I'm very capable of it. But if I want to live here for another 10 years, my knees aren't going to make it. So I probably don't want to lift today. But I'm not far away from wanting to. How do I design for the future? What are the things that I need to start to think about with regards to where do I put this stuff?
Yeah. Look, I think early engagement with a VT supplier could provide you all that information in terms of spatials. So you need to consider the lift well, the sizing. So when doors open, they obviously go out into the shaft. You need to make sure you have enough room for the doors to open. the cabin itself, you need to make sure that there's enough room for the rails and brackets for the cabin to go up and down in. So we need a certain dimension. The other requirements would be your pit, because as I mentioned before, the lift does not stop at your bottom floor. It needs pit for pit equipment. So the pit dimension is quite important, and the overhead dimension above where the last floor ends is quite important as well, because that's where your mechanical machines and things sit. So getting the spatials for, you know, a lift that you require in your home is quite important up front, and get that engagement so you know what you're looking at. And yeah, I think that engaging someone really early on in the design process is critical. But if you do have a home, you know, that you haven't thought about, you know, the spatials, we can definitely look at options like having a lift external to the house and cutting out openings and building a lift shaft on the outside. Now, we've done so many different things. Yeah, there's heaps of different options that you can consider. You just have to, you know, have a chat to your vertical transport supplier and see what we can do.
I love that it's called a vertical transport supplier.
Yeah, or Schindler. You can talk to Schindler.
Okay, so other than the dimensions, obviously we touched on this a little bit earlier, but we need to think about, hey, we want to put all the electrical cables and that sort of thing in place, or if we don't actually put cables, that we actually put, I guess, PVC piping and draw wires to actually pull the cables through at some point in the future that go all the way back to our switch box. So that very, very small cost at the, I guess, the point of construction can save you tens of thousands of dollars later on in trying to retrospectively put something in that doesn't work. Now, I can speak to going into houses where they have retrospectively put lifts in. So they, you know, they designed the house 3, 4, 5 years ago, and then as time progressed, they eventually went and put the lift in. They didn't think about some of these things, and so where you were talking about the doors retracting into the lift well, they didn't think about the dimensions of that, and so they were forced to do swing doors on a lift. And so if you don't plan it well, folks, you can actually get it to a position that when you actually do go to do it, you might be able to get it to work, but it might not be the best looking outcome or best feeling outcome. So be extraordinarily careful in that space. So the lift, so obviously the cabin size, important. The cabin size then has, I guess, a bit of room all around it. So that's the lift well. Then you've got where the doors need to retract into the lift well. Then you've got the pit below the lift well, and then the machine room if you need one, or at least the headspace above. So all of those dimensions need to be catered for and thought through very, very carefully right at the very start. So
they're quite critical dimensions if you do or anticipate to have a lift in the build. So yeah, early engagement is key.
Are the dimensions that go into those fairly standard in the industry? So if you know, if lo and behold, somebody thought about this 5 or 6 years ago and they had engaged with another company and then they want to put a Schindler lift in today, are those dimensions pretty universal?
They vary from product range to product range. So typically I would suggest to, you know, if you're going to purchase from one supplier, make sure that you're using their spatials and their requirements. We do have a bit of a crossover, but again, it's very dependent on what lift you're putting in there and what sizing we require. So yeah, I can't stress it enough, early engagement to make sure that those, you know, spatial and the dimensions work with what lift you want in your residence.
Yeah. Now, you then, I guess, in some jurisdictions, there are then some legislative overheads and compliance problems that do come in from time to time that you also need to be conscious of. Less so in an individual home perspective. So if you're doing a house or a townhouse or something along those lines, but if you're doing it in a public space, I believe that New South Wales has some challenges that are not insurmountable, but do add some extra complexity to the process.
Yeah, we have a process called design practitioner, which basically means we will have to sign off the project as a whole before you actually start development. So with design practitioner means you'd have to give us your architectural drawings. We would obviously give you the spatials for the lift requirements, and at that stage we'd have to look at fire components, access components, and then get it signed off by a design practitioner before you could move on to actually building your small commercial or residential build. So just something to keep in mind moving forward in the New South Wales space.
What I would say also, knowing that all bureaucratic governments tend to follow the lead of the other ones, be very, very cautious, even when you're in the other states, that this legislation doesn't get retrospectively applied. So always be conscious that when you're engaging with your vertical lift supplier, that you're asking all those questions with regards to compliance requirements that you may have to actually go through to. Very, very informative, Effie. So thank you very much. The $1 billion question that everyone really wants to know is it $1 billion? So if we're wanting to budget for something like this, obviously very difficult for you to give us an actual price point, and I'm not asking for that, but an indicative price range. If they're trying to do something in the smaller size, whether it be for 2 or 3 stories or up to, say, a 5-story apartment complex, what budget range might they be considering, I guess, to factor into their feasibilities?
Yeah. Look, if you want gold-plated lift interiors, then budget that $1 billion. But if you're wanting your standard, residential sort of lift, budget from about 75, 80 up until 120 for a bit of a higher end finish. So somewhere in that category. But it's always important to, reach out, get a quote, and see where we land with what you require for the building.
Absolutely. So, Effie, very informative. Thank you very much for, I guess, your input today. Is there any parting words of wisdom that you would like our audience to have with them before they run away?
No more Schindler List jokes. We always get that quite a bit. But honestly, getting early engagement would be the main one. We see, like you mentioned, a lot of people that start build and haven't really thought the process through. Getting in and understanding the requirements, the spatials, what we can offer, what your actual design intent is. So maybe that the lobby then can flow into the lift. Having that seamless design with your lift contractor is quite important. So make sure you do that early on and give us a call. Happy to assist in any developments that are coming up, and we're here to support.
Very good. Well, thank you, Effie. That's been greatly appreciative. Now, not only do we have industry experts on our Sunday sessions here, but we also have them at our regular monthly networking events we run all the way around the country. We run these Brisbane, Sydney, Melbourne, and Adelaide. If you want to come to a physical event, we also live stream them. So no matter where you are, please click on the links below. We'd love to see you at one of our upcoming meetups. Effie, thank you very much for your time, and we hope to see you at one of our meetups real soon.
Thank you for having me. Appreciate it.
No worries. Bye-bye.
Bye.